You fuck up so much, though. Why are you talking about emotion? Have you read Kahneman? And again, no, it doesn't free it up from the bugs. It can reduce some of the effect of some of the bugs. It can reduce their synapses, and it can. But what do you mean formal logic is a tool that can purify and extend the mode of thinking, actually? You mean if a human brain, through recursive cognition, uses some of the rules of reasoning and formal logic? No. What are you talking about purify? Anyway, because our propositional reasoning frees us. Purify, that's going to get a yod. I don't understand what you're saying. Are you talking about a practice that like we can do on pen and paper that we have the capacity to do? And why are you talking absolutes like purity, freeing twice in 3 lines? Because our propositional reasoning frees us from similarity and stereotypes, it enables the highest achievements of human rationality, such as science, morality, and law. You understand? Science, morality, and law, that's the cream of the crop. Not even the best brains. It's the best of the best brains. It's the best work of the best brains. Like no individual brain could have done like any of the important shit in science, morality, and law. But a couple really great ideas in an individual brain combined with a couple ideas from some other individual brains, and these brains I've mentioned so far are completely unlike the average brain. Though porpoises fit into the family resemblance among fishes, the rules that define membership in Linnaean classes, like if an animal suckles its young, then it is a mammal, tell us they are not in fact members. Through chains of categorical reasoning like this, and I would rather say categorical associations, we can be convinced that humans are apes, the sun is a star, and solid objects are mostly empty space. In the social sphere, what? Through chains of categorical reasoning like this, who is we? How many humans are convinced that they are apes? That the even that the sun is a star? And that solid objects are mostly empty space. In the social sphere, our pattern finders easily. Who is this written for? Because you would think this is supposed to be written for the public. But then I wouldn't think that because I would not want this in the hands of a layman. All right. Through chains of categorical reasoning like this, we can be convinced that this is, you know what? It's like Malcolm Gladwell's Blink. Fantastic book. Learned so much from it and hated, and hated uh, literally every time it was ever cited to me. Hey, Eris, hey, have you read Blink? Yeah, basically, we can like walk into a room and just know everything. Okay, look, yes, there were some experiments that yes showed that yes, a stranger can walk into a person's bedroom and correctly discern things about that person that their best friend did not demonstrate knowing on the test or doesn't know about the person. Yes. The brain is incredible. Yes. Observation, it is all incredible. Yes. But what I don't like that this information, but we already have that. Everybody already takes that to the extreme. That like talking about intuition and like the magic of it and so on. So they see experiments like that and they think I can walk in a room and I know 100% these things and I can trust my confidence in these things. Look, Malcolm Gladwell said I can trust my confidence in these things. But Malcolm Gladwell isn't as confident as you are in his first impressions. He knows that they may be fantastic, but he also knows they might not be. And Pinker, you know that we are quote unquote technically not logical. You know there's no free will. You know there's, hopefully you have some idea that there's no consciousness. And it's like, in order to maybe communicate with the public, you've used all these words, but you know you're speaking to brains. You know about the confirmation bias. You know that certain things have to be drilled in, hammered down, and so I just don't. I just feel. All right, well, I think I've been clear. In the social sphere, our pattern finders easily see the ways in which people differ. Some individuals are richer, smarter, stronger, swifter, better looking, and more like us than others. But when we embrace the proposition that all humans are created equal, if X is human, then X has rights, we can sequester these impressions from our legal and moral decision making and treat all people equally. Yes, and absolutely fucking no. We can create a system, take the best of the best, and create a system, absolutely, have some rules like this. And then what we say is, no matter what what you think, we have agreed, if X is human, then X has rights. So no matter what garbage is happening in your brain where like that's not true, we that's a bug. And the system can be bug resistant by the best of the best agreeing on things. I don't mean just the elite deciding things, but the ideas coming from the best. Anyway, um, but that is not who is we? Who is we? Because you can say all humans are equal all you like. I'm not going to be treating people equally. That's why I need to. So if I'm hiring people, or if I'm punishing people, all right. Well, what's an example that corresponds to if X is human and X has rights? I don't bloody know. But how I treat people is not rule based. It's just that when you're like, hey, Eris, please like actually try to think, get some pen and paper out, then I can try to consult the rules. And if I have humility, I can be like, clearly I'm violating this agreed upon rule. But it's not rule based, bro. So you have upset me with the whole more of this judge myth thing. We can sequester. I mean, yes, like that's the idea. So then, no matter how racist I am, we have laws in place that that you know that for that compensate. But I don't want anybody hearing me reading this. If you want to read the book and then think, oh wow, yeah, humans are blah, 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 they're so amazing and like rational and whatever, fine. But it cannot be from this reading of it. I refuse to propagate this nonsense. But when we embrace the proposition that you can embrace, you can integrate, but you still won't integrate the thing. So we're definitely putting him down as integration myth. And we're going to give him this page, integration myth 109. You can add that in, but it can't. How are you going to make it just like, what? Ugh. Surgically, if you surgically install the proposition that all humans are created equal, and surgically remove or chemically, like through some chemical process, you remove the less useful found it. So I call them, there's two kinds of its. They're writ its. Well, this was before they were called its. So it's writ voices and found voices. So the writ ones, or are those this? Yeah, no. Or I don't know. The found ones are definitely the ones that are pre-installed before you are a mind thinking about itself. So when you're nothing but genes millions of years ago, there are a whole bunch of it's being installed in the eventual brain that you will be. And then when you're like, oh, okay, I'm a brain. So what are some of the mechanisms in here? And then what are some good mechanisms that I should have that maybe either I don't have or aren't very strong? You've got to be shitting me. Fuck. I'm trying to export that Austria video and the hard drive just disconnected. Fuck. Why? All right, let's try putting it. All right. Anyway, so yeah, and then you can have your, I think the Ritz. We'll call them Ritz. Foundits versus Ritz. So that's spelled W-R-I-T-S. And those are the things that you can install. The Foundits are going to remain. And just a question of making the Riddits have thicker lines than the Foundits. That's all. Sequester these in. And yes, okay. We can sequester these impressions from our legal and moral decision making. Yeah, so like the government systems, whatever, can sort of, we can sequester those things by replacing them with, certain rules that we, yeah, sure. But then the whole we treating all people equally, but anyway, I've made my point. And the next chapter will be chapter 4, probability and randomness. This video is probably done over 2 videos, actually, or maybe 3. All right, there you go. 2024 Albert 30 Braber. I am looking for interns. The one thing, just to let you know, that I don't have to, that isn't part of my workflow, is now, thanks to iPhone being able to, capture text. I don't have to type all the words. Of course, I could just probably find an ebook anyway. But what I do need, from my fellow risers, if anyone is looking for an internship, if you've saved up or you know someone who wants to contribute, get you a camper. Come out here. Actually, no, you can do it from your parents' basement. Here's what I need. How about some editing of I don't want to make my videos super edited. It's really just what I'm doing now of putting this text on the screen. That takes so long, and honestly, my brain loves it. It's the perfect thing for. It's like the perfectly tedious, but also interesting thing, and I just go on autopilot and I do it. But I would love to get through this book a little more quickly. Okay. All right, we'll put you there and try to remember not to speak too loudly. Okay. Chapter 4, probability and randomness. Oh, I'm cold. I'm closing the door. It's not really an intern. I mean, it was just kind of a joke. But someone who just wants to get on board, we've got other members, but a lot of people are busy. Actually, when I said we have other members, I thought of Leo, so that's one person, and he's busy. So you maybe are less busy, since you are watching this, spending this time with me. So, all right, let's get to it. Okay, so we have here a quote from Samuel Johnson. Who was he, an economist? Or no, who's Samuel Johnson? An English writer. Okay. An English writer made lasting contributions as a poet and playwright and blah, blah, blah. The Oxford Dictionary of National Biography calls him arguably the most distinguished man of letters in English history. This is an 18th century English writer. Okay. A thousand, a thousand stories which the ignorant tell and believe die away at once when the computist takes them in his gripe. I like that. Though Albert Einstein never said most of the things he supposedly said, he did say in several variations, "I shall never believe that God plays dice with the world." Whether or not he was right about the subatomic world, the world we live in certainly looks like a game of dice, with unpredictability at every scale. The race is not always to the swift, nor the battle to the strong, nor bread to the wise, nor favor to those of skill, but time and chance happen to them all. An essential part of rationality is dealing with randomness in our lives and uncertainty in our knowledge. Section: What is randomness? Where does it come from? In the strip below, Dilbert's question awakens us to the fact that the word random in common parlance refers to two concepts: a lack of patterning in data and a lack of predictability in a process. When he doubts that the consecutive nines produced by the troll are truly random, he's referring to their patterning. Okay, so tour of accounting. Over here we have a random number generator. 9, 9, 9, 9. Oh, this is a different character. Okay. 9, 9, 9, 9, 9, 9. I lost count. I think I was at 9. Are you sure that's random? That's the problem with randomness. You can never be sure. So when he doubts that the consecutive nines produced by the troll are truly random, he's referring to their patterning. So going back again, there's two concepts: a lack of patterning in data and a lack of predictability in a process. Don't think I understand yet. Dilbert's impression that there's a pattern in the sequence is not a figment of his imagination, like seeing butterflies in ink blots. Non-random patterning can be quantified. Brevity is the soul of pattern. We say that a data set is non-random when its shortest possible description is shorter than the data set itself. The description 6 nines is 2 characters long in an efficient shorthand for the descriptions, whereas the data set 9999999 is 6 characters long. Other strings we feel to be non-random also submit to compression. 1, 2, 3, 4, 5, 6 boils down to first 6. Oh, like the first 6. Okay, first 6. 505050 squashes down to 350s. In contrast, data we feel to be random, like 6, 3, 4, 5, 7, 9, can't be abridged into anything more concise. They must be rendered verbatim. That's magical. And I just want to make sure okay. How we qualify something, whether we describe something as being random or not, one of the determiners of that is how compressible it is, or whether it's compressible. So if you can, as he said, state the whole set by describing its pattern, if you can save time by describing it, then it's like a pattern. And we have an it that goes, if compressible, then not random, which is a pretty good it. It's not, in reality, it's a pretty good it. Sort of logically, it's not going to work and it's not really justified. But that strikes me as a pretty good rule of thumb to have in the brain, or a pretty good heuristic, a pretty good it. That if compressible, then not random. It's not logically justified, though, of course, because determining the randomness of something can't actually be done by looking at whether it's compressible. That's just sort of an inductive hint, if I'm using that word at all correctly. But you can't actually deduce from that. Please tell me whether what I just said was not bullshit. Okay. The troll's answer captures the second sense of randomness. And I want to pause for the page change, but not anarchic, an anarchic, unpredictable generating process. Right. The troll's answer captures the second sense of randomness. An anarchic, anarchic. Okay. The troll's answer captures the second sense of randomness. An anarchic, unpredictable generating process. The troll is correct that a random process can generate non-random patterns, at least for a while, for 6 digits worth of output in this case. After all, if there's no rhyme or reason to the generator, what's it to stop from producing 6 nines or any other non-random pattern, at least occasionally? As the generator continues and the sequence gets longer, we can expect random patterning to reassert itself because the freakish run is unlikely to continue. The troll's punchline is profound. As we shall see, mistaking a non-random pattern for a non-random process is one of the thickest chapters in the annals of human folly. And knowing the difference between them is one of the greatest gifts of rationality that education can confer. I don't know that I understand. I agree, but I'm just also going, wait, are you, I just don't know how much, I don't understand why. One is one of the thickest, sure, okay. The whole correlation causation, or just, yeah, I mean, it's a good it to interpret a non-random pattern as coming from a non-random process. But it's not actually a true sort of it. It's a useful one. It's pretty adaptive, or adapted, or advantageous. But of course, you need to know that it's not actually like true, so that you can check when you've concluded that a process is not random. Make sure that your only reason for that isn't that that's a non-random pattern. Now you can't really do that. You can't just like run a log check of your own mental processes. But what you do is you go, okay, I think that's a non-random process. All right, why do I think that? Well, look, I can describe this. Oh shit. Okay, no worries. Why else do I think that? And then you evaluate the next things that come out. Because remember, we all have it's a tendency to, anytime we assert something or need to defend something, all right, picking up where we left off an hour ago, whatever. All right, so aging, the agits, are any time that there's a sequence run in the brain where the output, the delivery, no. All right, so let's say that the delivery is some belief or statement. And suppose that following this delivery, there is now an input of challenging, okay, of disagreement, of dissent. Okay, that input, there's a whole gang of dudes, whole gang it's. I don't really have a word for. Well, anyway, there's a whole gang of it's that are just sitting there waiting, watching, waiting for the if challenge to something else that came out of this system. It's not even them that like made the original delivery that's now being challenged. They had nothing to do with it. Well, you can imagine it this way. Imagine the brain as a building. And you imagine the front entrance of our building is actually on the side. But sort of near the front. Okay, that's Broca's entrance. Okay. Sorry. This is the exit, actually. Oh, shit. I really want it to be. All right. Well, anyway. This is, stuff from the building gets sent out through this big main door. Okay. And then the entrance is a bit further down. And there's an office, a reception office at the entrance. Now, the reception office at the entrance doesn't know what's going on at the dock, of the truck loading. Big Broca's door that we were talking about. I mean, obviously they get maybe a memo every once in a while, and and they're all trained at the same place, sort of, not really. But anyway, because integration is not true, well, we've got these receptionists who sometimes don't know what's being loaded in the trucks and sent out. Okay. Now, among this reception team is a gang of dudes. Super, what do you call it? High end, whatever. And their whole thing is, if anybody comes in here with a return, if anybody comes in here with a complaint, I don't give a shit what product we sold them. I don't give a shit what the product was. I'm going to go there's a whole bunch of dudes waiting with that if we get a complaint. And then they each have a different then. One of them is going to go get 2 Coke, who is going to come here and say, no, you're the problem. 2 Coke or whatever. Another one is going to go trigger, I don't know, semantic equivocation. Anyway, they're just going to get reinforcements to justify whatever the original delivery was. And sometimes it'll have nothing to do with the actual quality of the delivery. So you have to know you have those dudes in your customer service department, in your reception office. You've got those dudes who are just not going to, okay. I think we should just move on now. Those dudes are there. So where were we? At the bottom of page 112, the troll's answer captures the second sense of randomness. An anarchic, unpredictable generating process. The troll is correct that a random process can generate non-random. Oh, right. So we had this non-random pattern being taken as an indication of a non-random process. Right. And then what we were talking about is that if someone or one of your own its challenges this assumption or this association or its usefulness here or its application here of non-random pattern to is indicative of a non-random process, just know that when that happens, the non-random pattern equals non-random process is going to call in reinforcements. And we just always have to be careful of that. So even if you have this great gift of rationality and education of knowing the difference, even if you've got one id in there, you still got to fight a bunch of dudes that are wired in there to back up the instinct of a non-random pattern indicating a non-random process. I don't really remember what my point was. It was quite a conversation I had in the interim. All this raises the question of what kinds of physical mechanism can generate random events. Einstein notwithstanding, most physicists believe there is irreducible randomness in the subatomic realm of quantum mechanics, like the decay of an atomic nucleus or the emission of a photon when an electron jumps from one energy state to another. It's possible for this quantum uncertainty to be amplified to scales that impinge on our lives. When I was a research assistant in an animal behavioral lab, the refrigerator-sized mini-computers of the day were too slow to generate random-looking numbers in real time, and my supervisor had invented a gadget with a capsule filled with a radioactive isotope and a teensy-weensy Geiger counter that detected the intermittent particle spray and tripped a switch that fed the pigeon. But in most of the intermediate-sized realm in which we spend our days, quantum effects cancel out and may as well not exist. So how could randomness arise in a world of billiard balls obeying Newton's equations? As the 1970s poster proclaimed, making satire of billboards about the speed limit, gravity. It isn't just a good idea, it's the law. In theory, couldn't the demon imagined by Pierre-Simon Laplace in 1814, who knew the position and momentum of every particle in the universe, plug them into equations for the laws of physics and predict the future perfectly? Well, I was 100% counting on that when I was in high school, that would be a future possibility. Did I know about this? Pierre-Simon Laplace. All right. In reality, there are two ways in which a law-governed world can generate events that for all intents and purposes are random. One of them is familiar to popular science readers, the butterfly effect, named after the possibility that the flapping of a butterfly's wings in Brazil could trigger a tornado in Texas. Butterfly effects can arise in deterministic nonlinear dynamical systems, also known as chaos, where minuscule differences in initial conditions too small for any instrument to measure can feed on themselves and blow up into gargantuan effects. The other way in which a deterministic system can appear to be random from a human vantage point also has a familiar name, the coin flip. The fate of a tossed coin is not literally random. A skilled magician can flick one just so to get a head or a tail on demand. But when an outcome depends on a large number of tiny causes that are impractical to keep track of, like the angles and forces that launch the penny... Who flips a penny? And isn't it an avalanche? And the wind currents buffeting it in midair, it might as well be random. So what are these two ways? So I thought he was going to say that as long as we don't see a pattern, or as long as we couldn't have predicted it, then we could say it's random. I mean, as long as we didn't predict it or we didn't know how to predict it, then it qualifies as random. But there are two ways in which a law-governed world can generate events that, for all intents and purposes, are random. one, so it's just a bunch of combinations of like little things. And so then it's like, how'd you go from that to that? Which I think is kind of this on the same, in the same vein as what I'm saying. I don't know. And then the other way in which a deterministic system can appear to be random is that there are these micro causes, but happening at the same. I don't understand the difference between these two things. You've got the butterfly effect, which is a whole bunch of causes that are a large number of. Is it the word tiny? Because I see the butterfly effect as an outcome depending on a large number of causes that are impractical to keep track of, like the air force, the wind currents buffeting its wings in midair, and the angles and forces of the warm and cold air somewhere in Austin. Just seems to be the time is different or something. All right, whatever. Moving on. Okay, we're gonna get cut off, by the way. All right. Section, what does probability mean? When the TV meteorologist says there's a 30% chance of rain in the area tomorrow, what does she mean? Most people are foggy about the answer. Some think it means it will rain in 30% of the area. Others think it means it will rain 30% of the time. A few think it means that 30% of meteorologists think it will rain. And some think it means it will rain somewhere in the area on 30% of the days in which a prediction like this is made. That's what I would have thought. The last of these is in fact closest to what the meteorologist had in mind. Okay. Weather watchers are not the only ones who are confused. In 1929, Bertrand Russell noted that probability is the most important concept in modern science, especially as nobody has the slightest notion what it means. More accurately, different people have different notions of what it means, as we saw in Chapter 1 with the Monty Hall and Linda problems. There is the classical definition of probability, which goes back to the origins of probability theory as a way of understanding games of chance. You lay out the possible outcomes of a process that have an equal chance of occurring, add up the ones that count as examples of the event, and divide by the number of possibilities, by the total. A die can land on any of 6 sides. Oh, not the total. Okay, by the number of possibilities. Okay. A die can land on any of 6 sides. An even number corresponds to its landing on the sides with 2 dots, 4 dots, or 6 dots showing. With 3 dots, it can land even out of the 6 possibilities in all. With 3 ways, it can land even out of the 6 possibilities in all. We say that the classical probability it will roll even is 3 out of 6, or 0.5. In Chapter 1, I used the classical definition to explain the correct strategy in the Monty Hall dilemma, and noted that miscounting the possible outcomes was what lured some of the overconfident experts to the incorrect strategy. But why did we think that the outcome of landing on each face had an equal chance of happening in the first place? We assessed the die's, I was waiting for this word. We assessed the die's propensity, its physical disposition to do various things. This includes the symmetry of the 6 faces, the haphazard way the shooter releases it, and the physics of tumbling. Closely related is a third, subjectivist interpretation. Before you fling the die, based on everything you know, how would you... Sorry, I haven't been underlining. What is the difference here? And why don't you talk enough about human perspective there? You say impractical to keep track of. Okay, yeah. Okay, so we have this classical definition of probability. So that's one. There's a classical definition of probability, which you have the number, you run it out, then you have the number of qualifying events versus the number of possible events, okay? But why did we think that the outcome of landing, why we assess the die's propensity, its physical disposition to do various things? Who did? When did we do that? Why are you saying that? In any case. Alright, so propensity, is this the second thing then? More accurately, different weather watchers. Alright, closely related is a third. That's why I'm wondering what these numbers are. Now we're on third. So it's propensity 2 and classical 1. That's what's in italics. Closely related is a third, subjectivist, in italics, interpretation. Before you fling the die, based on everything you know, how would you quantify on a scale from 0 to 1 your belief that it will land even? This credence estimate is sometimes called the Bayesian interpretation of probability. A bit misleading, as we'll see in the next chapter. Credence estimate. Propensity is physical disposition. And then the classical definition is examples of the event and divided by the number of possibilities. 3 is subjectivist. Now, then, there is the evidential interpretation, the degree to which you believe the information presented warrants the conclusion.